Okay, while on the other boundary, on the left boundary, because the characteristic actually crosses the boundary into the domain, we can specify any solution we want. I mean, it doesn't seem to be making a difference between this part of the boundary and the initial condition, right? You can specify the initial condition to be whatever you want. You can also specify the left boundary condition to be whatever you want. So the right way to specify the initial and the boundary conditions in this space-time slab is the initial condition at the lower side of the time domain and also on the left side of the spatial domain. The trick is here, the trick is the difference between the left and right is on the left, the characteristics are crossing the boundary into the domain, while on the right, the characteristic is crossing towards the right out of the domain. Agreed? Okay, and if you have another scenario where the characteristic speeds are negative, it's actually the opposite way. The characteristic, they can go at different directions, but they always go towards the right. And now if you are solving between the domain left and right, the correct way to specify the boundary and the initial condition is that you still specify the initial condition, but then you have to specify the boundary condition only on the right and not on the left, because there is no way for you to both specify initial condition here and the boundary condition here. They would contradict each other. Well, if you don't specify boundary condition on the right, you wouldn't even know, for example, what the solution could be here, right? Because the solution here is determined by the boundary condition when the characteristic crosses into the domain. All right. So the general rule is that, by the way, if you have a scenario where sometimes the domain crosses into the left and sometimes crosses into the right, then the boundary condition actually varies. It'll actually depends. So for example, if you have a case where on the left the boundary condition, the characteristic goes into the domain, on the right it also goes into the domain, right? Then it's actually appropriate to specify a boundary condition on both sides, because on both sides the characteristic crosses in. While if you have the opposite scenario where you have characteristic going out of the domain on both sides, then it is appropriate to specify neither left or right boundary condition. You can only specify initial condition, right? Because that'll conflict with any boundary condition you specify on either side. Okay, questions? So this is when it makes sense to specify boundary conditions. And I'll quickly talk over how to specify boundary conditions in the discretization. And I'll show you a pretty simple example when I have an initial condition that's all positive. Okay, so which I basically add a 2 to the initial condition to make sure everything is positive. So if the solution U is positive, the wave speed is positive, and which side should I specify the boundary condition on based on our graph earlier? Hello?
It's always positive, right?
Yes.
So we should pick a boundary condition coming from the left side.
Yeah, we should specify boundary conditions coming from the left and leave the right as no boundary conditions, right? Okay, so in this case, let's say I want my boundary condition to be consistent with what I have as an initial condition, right? My initial condition, I'm saying the U is a sine of 2 pi x plus 2. And the sine of 2 pi x plus 2 would be equal to 2 when x is equal to 0. So let's set the U boundary left to be equal to 2. and let's see how do we enforce the boundary condition. Okay, actually, I think I want to specify the boundary condition in this Burger's code. All right. So in this case, when I look at an interface on the left of every domain, the U that lies to the right of the interface is still U, but instead of having the U end that lies on the left of the first interface, I would have U boundary L that would lie on the left of the first interface. Agreed? Okay. And also, I would also have to basically, well, I actually don't need to do anything here because so this is the case when, if you look at this line 28, because my U average is always greater than 0, I would only always be looking at the left of the interface. So my left of the interface is actually this. But in reality, when I have boundary conditions that are not periodic, and I have n volume averages, I actually need to track n+1 interfaces. Right? I mean, that's actually the one of the biggest difference between a periodic and the non-periodic boundary conditions in finite volume is that for periodic boundary conditions, because of the periodicity, if I have n volumes, I only have n interfaces. But for non-periodic, if I have n volumes, I actually have n+1 interfaces. If you remember, if you look at, well, this is too fine for you to actually see, but for example, if I go back to our lecture 10 and file up the finite volume demo,